So here are the basics of a titration. What we have is a titrant right here that has a known volume. It's in a burette, and we can measure the volume very accurately. We can know the concentration of this substance that's put in here, usually a base or an acid. And then we have an analyte here that is the opposite of whatever this was. So if this was a base, this would be an acid, or vice versa. Now we do know this volume, we can put it in a graduated cylinder, but we do not know its concentration. And the whole idea of this experiment is to determine its concentration. So what we will do in the course of a titration is we will add, in this case, we are starting with an acid. We know that because we start with a low pH. And if we add base to it, it will slowly increase the pH. Now it will mostly still be acid, still be acid, still be acid, and then you'll get a very sharp point. At this point right here where the slope is undefined, this is at the equivalence point. So this will be a strong acid, a strong base. Note that it starts about here, and then for a strong base with a weak acid, note that the pH is about, starts a little bit higher, and it does flatten off a little bit, but you still get that notable point in the middle. Now you could also start with the other way, where we are actually titrating an acid here, but we start with a base. So we get these notable curves and these equivalence points right here. Notice how they happen very quickly. At about 49 milliliters, you were on one side, but 51 milliliters, you were very far on the other side. So you have to be very careful and very precise to make sure you want this point. This is actually the only point you're really concerned about. If it is a diprotic acid, meaning it has two protons, sometimes you can have two equivalence points, but that is another lesson for another day. Now the equivalence points were where the moles of acid equals the moles of base, but how do you know that that is it? Because both of them are colorless substances. So how do you know it changes? Well, what you do is you put an indicator in there. An indicator is something that is going to change the color. And so it is going to be, put the indicator in there, it looks like this. We start adding the titrant, and we note the volume here, and then we will add the titrant until the indicator changes the color. Notice how the volume goes up here. We are not going to measure this volume. We're going to measure this volume at the beginning of the titrant, and this volume, the second volume. We're going to take the difference, and that is the volume that was added to this Erlenmeyer flask. So those 2 points, that point at which the indicator that changes color is called the end point. Now the equivalence point was the point that I was pointing out earlier on the graph. It was that sharp curve. Now you really want them to be the same point, but they mean two different things. The equivalence point is called the stoichiometric point, is where the moles of acid equals the moles of the base. And that is where you can do some one-to-one stoichiometry there. That is when stoichiometry happens. Yay. So you can use many different indicators. This is the best graphic that I have. The most common one is phenolphthalein over here, which is what we'll use in our lab. Now, that is if you are using a strong base with a weak acid, or if you are using a strong acid and a weak base, you probably would use methyl orange. It's over on the other side because that is where the equivalence point will be, is around there. Or if you're doing strong acid, strong base, you could probably use bromesyl purple or bromothymol blue. And that would be it. You would not want to use a universal indicator because it spans the whole different colors, and although you could see all the different colors and it would look cool, it doesn't tell you the best information. So there are a lot of other calculations we could do, but that's another video for another day, so have a great day.